In these next set of examples, we are going to complete the square when our a value is not 1. So if the number in front of the square term is anything other than 1, we are going to have an extra step at the very beginning of our problem. So the easiest way to take care of that is to force the x squared to be a 1. So if we're going to do that, we're just going to go through and we are going to divide everything by whatever number is in front of the square term. So this may mean that we might have to deal with fractions kind of temporarily. So for number 5, since we have a 4 in front of our square term, the very first thing that I'm going to do, since we are solving by completing the square, is divide everything on both sides of my equal sign by 4. Okay. So those are going to cancel. So we would have x squared. 20 divided by 4 is 5, so 5x. And then 1 divided by 4 is a fraction, and we're going to leave it as a fraction. So it's going to become 1/4. And then 0 divided by 4 is still 0. Okay. So now we're going to go through and we're going to complete the square the same way that we've always done it. So I'm going to move my constant over, leave room to complete the square. All right, so now we have x squared plus 5x plus, and I'm going to leave a space, equals our negative 1/4. And we're going to add that same number to this side. So again, it is the middle term divided by 2, and then we would square it. So same thing on this side. So the middle term divided by 2 squared. So when I continue, we're just simplifying to start with. So this is going to be x squared plus 5x plus, and then 5 squared is 25, 2 squared is 4. Okay. So negative 1/4 plus 25 over 4. Okay. And then now we have to factor. So when I'm looking at this, it's kind of hard to recognize what two numbers would multiply to be this last term and add to be the middle term. So if we go back and again look at our previous examples where I pointed out that shortcut, whatever the number is before we square it is what is ending up inside our parentheses. So I'm going to use that rule. So inside our parentheses we will have this x and then a squared. Now I'm going to go back to this previous step. So I'm using this 5 over 2 and it's positive. So I'm going to put plus 5 divided by 2. Okay. Now just to verify that that works, again we're looking for two numbers that multiply to be 25 over 4. Okay. And again we picked 5 over 2 so that would happen. So now if I do a little bit of side work here, if I take 5 divided by 2 plus 5 divided by 2, that needs to be 5. So if I add, 5 plus 5 is 10 over 2, which does simplify to be 5. So I did pick the correct term. Okay. But sometimes it's hard to recognize that when we are working with fractions. So for that kind of problem, I would recommend using that shortcut rule to make it a little bit easier. And then on the other side, we still want to combine those. So they already have a common denominator, so I'm just combining the tops. So this is going to combine to be 24 over 4. And normally we would want to simplify that fraction, but notice that your denominator is a perfect square, so we don't want to simplify yet. So we're actually just going to leave that as is. So now we're going to take the square root of each side. So again, this is going to cancel out. So we have x plus 5 over 2 equals, and then we would have the square root of 24, so that's not a perfect square, but I can think of 24 as 4 times 6, and then I can take the square root of 4 in the bottom. So in the numerator, the square root of 4 is 2, so that's going to come out, and we do have a plus minus still. 6 stays inside of our radical, and then the square root of 4 is 2. So 2 divided by 2 is going to cancel out, so I'm really looking at having x plus 5 over 2 equal to plus and minus the square root of 6. Okay. And then my last step would be to subtract the 5 halves over. So this is going to be x equals negative 5 divided by 2 plus and minus the square root of 6. And this would be the final answer. All right, so let's do another one. So again, I have a number in front of my squared term. So before I do anything else, I'm going to go through and I'm going to divide everything by that number on both sides of the equal sign. So now we have x squared equals 6/5 x plus 8/5. So to complete the square, I need my square term and x on the same side. So this time I'm going to subtract the x term, put it on the same side with my squared, and the squared does have to be positive for us to complete the square, so we don't want to move that one. And then as I subtract it over, I'm going to leave space to complete the square. Okay. So we will have x squared minus 6/5 x plus, and then leave room to complete the square, equals a positive 8/5. And again, we're going to leave room to complete the square. Okay. So again, I'm taking my middle term, so negative 6/5, dividing it by 2, and then squaring it. So I'm going to simplify that. So remember, when we are dividing fractions, we multiply by the reciprocal. So this is really, when I say negative 6/5 divided by 2, I'm going to keep the top fraction. So negative 6/5. I'm going to switch to multiplication, and I'm going to flip the denominator over. So 1/2. And then we would multiply straight across. So this is going to become negative 6/10, which I can further reduce to be negative 3/5. Okay. So on this side, I'm going to write that one. So negative 3 divided by 5 squared. Okay, so now we're going to go through and simplify. So again, I'm going to use my shortcut rule. So on this side, it's going to factor into x, and then I have a negative, so minus 3/5 squared equals, and then here we have to simplify. So we're going to have 8/5 plus, and then negative 3 squared is 9, 5 squared is 25, and then I need to combine like terms. So that means I need a common denominator. So I have to multiply this part by 5. So I'm going to have x minus 3/5 squared equals, and then if we multiply by 5, this will become 40/25 plus 9/25. And we just combine the top part of our fraction now that we have a common denominator. So x minus 3/5 squared equals 49/25. And then now we are going to take the square root of each side. So x minus 3/5 equals, plus and minus, square root of 49 is 7, square root of 25 is 5. So now I'm going to add that term over, so x equals a positive 3/5 plus and minus 7/5. Now, because I don't have a radical, that means that I have to continue simplifying. So remember, we are really solving two different problems. We have x equals 3/5 plus 7/5, and we have x equals 3/5 minus 7/5. Okay, so we're just going to simplify that. So they already have a common denominator, so I can just combine the tops. So 3 plus 7 is 10/5. And then 3 minus 7 is going to be negative 4/5. And I can simplify this one to be a 2. So my two answers for this problem is x equals 2 and negative 4/5. That would be my final answer. All right, one more problem. So again, I have something other than 1 in front of my x squared term. So I'm going to start by dividing everything on both sides of my equation by 2. So I will have x squared plus 1/2 x, leave room to complete the square, equals 3 plus, and then room to complete the square. So again, it will be half of the middle term. So I'm taking 1/2 divided by 2, and then I'm going to square it. So before I continue, I'm going to simplify this part. So if I'm taking 1/2 divided by 2, I'm really taking 1/2 times 1 over 2. So this will simplify to be 1/4. So on this side, this will be 1/4 squared. So now again, I'm going to use my shortcut to factor. So on this side, it's going to be x, and then since this is positive, it will be a plus, and then 1/4 squared on the outside equals 3 plus, and then 1/4 squared will be 1/16. So to combine this, I need to put this over 1, and then we need that common denominator. So I'm going to have x plus 1/4 squared, and then we need to multiply by 16, so 3 over 1 will become 48 divided by 16 plus 1/16. So we want to combine our like terms. So x plus 1/4 squared equals 49 over 16. Square root each side. So x plus 1 over 4 equals plus and minus. So square root of 49 is 7, square root of 16 is 4. And then I'm going to subtract my 1/4 over. So x equals a negative 1/4 plus and minus 7/4. So again, I have two separate problems that I need to solve because we can combine those together because we didn't end with a radical. So we need to simplify x equals negative 1/4 plus 7/4, and then x equals negative 1/4 minus 7/4. So they already have a common denominator, so we're just combining the numerators. So negative 1 plus 7 is 6 over 4, and that reduces to 3/2. And then negative 1 minus 7 is negative 8 over 4, which reduces to a negative 2. So my two answers will be negative 2 and positive 3/2. And that is going to conclude section 5.